Hello, my name is Jason Teplitz, and along with Yegor Jabanov, I worked on implementing web worker support directly into the Angular framework this summer while I was an intern on the core team at Google. And I'm here to talk to you a little bit about how that works, why we did it, and why we think it's a great idea, and you should check it out. And if we have some time, get to some really cool stuff that it lets you do. So before I talk about what are web workers, why do we use them, why do we think this is a good idea, I just want to go over a general problem that I think we've all seen on the web. And that is this horrible dialog box that shows up after you use a web application and it tries to do something and it just utterly fails and it freezes and your computer is slow and you see this and you hate your life and hopefully it wasn't your web application, but maybe it was sometimes. We've all done it. And this is really bad. But why does this happen? And the reason that this happens is because traditionally the web has been this single process, single threaded model. And you share that single process with the browser. So what that means is, if you're running an application and you start doing anything that's CPU intensive, you have the potential to steal resources away from the browser and basically skip frames. And when you start skipping frames, it doesn't take a very long time before users notice this. And they do something, and an event fires, and then all of a sudden, the application doesn't seem responsive anymore. And that's when you start getting these horrible reviews like, oh, your app sucks, or it's so laggy, it's janky, how do I make this smooth? And when we're talking about making an application smooth and having a good user experience, which is, I think is something we all strive for, we're talking about 60 frames per second. This is the rate. If your application is running at 60 frames per second, users are not going to notice any delay between when they do something and when the result appears on the screen. So this is what we want. This is great. So let's do some math. Don't worry, it's not too hard. That means you have 16 milliseconds per frame to get a synchronous block of work done. If you take more than that amount of time, you're going to run over, you're going to skip a frame. Sooner you do that too many times, users are going to notice your application is going to be slow. It turns out on the web, though, that if you do a block of work that modifies the DOM, the browser needs about 8 milliseconds on average to update the DOM. So you actually only have 8 milliseconds to get your synchronous block of work done. So it's not a lot of time. And if you start doing too much, you're going to skip frames, and that's bad. So here's just a list of some things that can very easily take longer than 8 milliseconds to get done. You might have a large set of data that you need to parse. You might have images that you need to process or sound that needs to get processed. You might be running some sort of intensive algorithm, or you might have a very large table. We'll see in a little bit that large tables in some browsers are not optimized very well, and scrolling can be really, really poor performance-wise, especially if you're doing analytics or any sort of data visualization on that table. Now, there's sort of a theme to all of the things on this list, and that is that they're all things that modern web applications do more and more of. They're all things that we want in our applications, and they're all things that native applications do. So we'd love to do these things, but on the web today, we're really limited, and we really just can't do them without having poor user experiences. And this problem's even worse on mobile. This is the new Android One phone in India. It has a 1.3 gigahertz processor. At that speed, Chrome is pretty sluggish no matter what you're doing. And if you start doing something that's intended for, no, it's not screensaver. If you start doing something that's intended for a native application or something intensive, you're going to run into these performance problems pretty quickly. But there's something cool about this phone. It has a quad-core processor. And in fact, almost every processor created today, even the really, really cheap ones, have multiple cores. So how do we unlock these cores? How do we use the full potential of the phone? How do we have smooth applications? Well, one solution is web workers. It's not the only solution. There are other ways to do this, but it's one that we think is really promising. It's one we've chosen to focus on at the framework level. And I'm going to talk to you a little bit about how it works. Now, a web worker, this is not great. So a web worker is basically a separate execution context for your application. What that means is that it allows you to run some part of your JavaScript in a totally different process that can run in parallel with your UI. And that prevents blocking. So it allows you to run code that doesn't block. It allows you to also run your application code across multiple windows. So imagine that you're using Electron, and you want to write this native desktop application. You want it to feel like a native app. Native apps typically have multiple windows. And that's kind of tricky on the web because you have to have different JavaScript on the windows. They have to talk to each other. But what if they could all just drive the application logic from the same window and then push the UI to different windows? And the web worker infrastructure that we've built makes that really trivial. In addition, you can better compete performance-wise with native mobile applications. So if that's something that you're trying to do, if you're trying to avoid writing native code by writing web code, native applications all take advantage of multi-threading. So if you're not doing something parallel in your application, you're inherently going to be slower than any competition that you have. Also, if you write web worker components, you can test without the browser, right? A web worker component is a component that doesn't rely on the DOM, doesn't rely on browser APIs, and therefore doesn't need WebDriver or Karma to be tested. So you can write integration tests that run a lot faster, that aren't flaky, and that's a really great plus. And this feature, it might sound really new, but it works with all modern browsers, i.e. 10 and up. Now, there is sort of this other idea that you might have, which is, no, that's a bad idea. Things are hard. Hard things should not be done on the client. The web is not meant for that. The web, all JavaScript was ever designed for was changing colors on a page when I click something. I don't want to do anything more intensive than that. I'm just going to do it on the server. If I want to process an image or process some sound, no. I'm going to upload that to the server. I have these great server guys. They have a great server team. They'll take care of it. I have all these server resources. Great idea. And as it turns out, that's generally not a good solution for a number of reasons. If the data already needs to be on the server, if it started there, for instance, then that's probably a good idea to process it there. But if the data is on the device, it doesn't make a lot of sense to upload it. For one, you pay for server CPU usage. You don't pay for client CPU usage. So not utilizing the CPU usage on your client's devices is just losing you money. But that's not in any way the worst reason. Something that's really critical is that especially on wireless and mobile devices, it costs significantly more to transmit a byte than to compute it. Now, what do I mean by that? Imagine that you have some set of data, and you want to run maybe a linear algorithm or an O of n squared algorithm on that data set. If your approach is, oh, no, I don't want to waste local resources by running that algorithm locally. I'm going to upload to the server. I have these great servers. They can run the algorithm very efficiently, and then I'll download the result. Well, the problem is you're probably going to end up costing your users more battery life. Because, sure, your CPU is not doing much, but your radio is. And sending out radio waves is one of the most energy-intensive things that phones do. Typically, they don't reach the access point or the cell tower. They need to be retransmitted, especially if you're in a congested area or a poor cell service. So that energy cost ends up being really high, right? You're sending out giant RF waves in a spherical pattern. That tends to be more expensive than computing something locally. Additionally, I'm sure these are some numbers that a lot of people have seen. Jeff Dean is a principal engineer at Google. He basically built some of the coolest infrastructure that Google runs on and some of the most performance critical stuff. And these are numbers that I think he was just born with and then decided to tell all of us on this written slab that this is the way the world works, and everyone should know these. So as you see up top is local operations, things like reading from a cache or reading from main memory. Way down at the bottom is sending a packet round trip across the internet. It's around 6 orders of magnitude longer than reading from main memory. So if your approach is upload the data, run the algorithm, get the result, then you have to be sure that that algorithm is going to run at least that much faster on the server, or else the cost of transmitting is going to make the end result slower for your users. OK, so in summary, web workers are awesome. They are faster in some cases. They allow you to write much more responsive applications. They can be more battery efficient. They enable you to do better testing. They're supported in every major browser, unless you're an IE9 user, but or Opera Mini. But I don't think you guys are making decisions on Opera Mini. If you are, I'm sorry. This isn't the right talk for you. But in addition, they can save you money. So you have all of these great things. If you walked into your manager's office tomorrow and you said, hey, I can do all of these things with implementing this one feature inside of our application, they'd be like, why aren't you doing that? You should do this. This is amazing. It's sort of this golden feature of the web. So obviously, everyone's using it, right? Raise your hand here if you've used web workers before in an application. Cool. So you can't see this on the live stream, but I think in a room of many hundreds of people, 8 raised their hand. So people aren't using it, even though I just said it was amazing. Why might that be? And it turns out there's a lot of challenges with web workers. Web workers are similar to Unix process model, although not quite as tricky, but still pretty tricky. And they have no access to the DOM. They share absolutely no memory with your main process. And so what that means is that everything you want to do in a worker needs to communicate with your main process through message passing. That message has to be serializable. And that runs into concurrency issues that you haven't had on the web before. So it's very challenging to use web workers, and as a result, people don't. And that sort of led to this model of, OK, web workers might be helpful. Maybe my application needs them, but they're hard. I don't know how to use them. It's confusing. So instead, I'm going to write my application without them, hope and pray, cross my fingers that my application is not slow. And then I'll test it, discover performance problems, realize this module is slow, move that module to a web worker, and then it will be fast and I'll have no problems. And that's the paradigm right now. And that's a really bad idea for a couple of reasons. The first is you typically don't know what part of your application is slow. And what's not slow on your corporate MacBook has a good chance of being slow on a 3-year-old Android phone. And it's pretty hard to test across all those devices. Additionally, even once you know what is slow, it's non-trivial to move that code to a web worker. You wrote this code without these constraints in mind. It had access to the DOM. It used memory that other parts of your application used. You now want to take it and move it somewhere else. And that's not going to be easy. That's going to be bug prone, and you're going to have to debug it, and that's going to take time. So it's difficult to extract that logic. Essentially, web workers are hard. They might be helpful, but they're just hard. So this is Angular. The whole point of Angular is to make web development easier and fun. So let's make them easy. How do we do that? And the paradigm that we came up with is run everything in a web worker. Run your application logic in a web worker. Run as much of Angular's core framework in a web worker as we possibly can. And then let the framework take care of updating the UI. Let the framework take care of the synchronization and these concurrency issues. That's not your job anymore. So let me show you just how easy that can be. So here I have a demo of a large table. And this is just an example of some data that you might want to process. And in this case, I have some numbers that are generated, and I want to find their largest prime factor. I'm doing this all locally. And as I scroll through the table, it's going to try and load more results. But we'll notice pretty quickly that I'm scrolling, but nothing is happening. And this scrolling bar gets larger. More results are coming. Oh, crap, my browser froze. Why did I do this? This was a horrible idea. I should have paid attention to my theory class when this problem was called NP-hard. I should really know what NP-hard means, but I forgot. It's been a long time. So I actually have to force quit Firefox because this application is so crappy. And this is actually the first time I've ever been excited about force quitting something during a demo. Usually that ends really poorly. And so that didn't go very well at all. And that was a standard Angular 2 application written without web workers. So what if we wrote it with web workers? Now, that's probably hard, right? That was the whole thing that I just talked about, is that web workers are hard. But as it turns out, they're actually not that hard. So here is the index file for that application. And as you can see, I'm loading Angular. How do I use web workers instead? Well, it's actually pretty easy. All I have to do is load a different bundle. So instead of the Angular bundle, I'm going to load the web worker bundle, which is webworker/ui.dev.js. This basically just says I want the parts of Angular that live on the UI, not the parts that live on the worker. Once I do that, I'm going to go into my app. This is the entry point for my application. This is where I call Bootstrap. If you've seen any Angular 2 apps so far, this is probably fairly familiar to you. And instead of calling Bootstrap from Angular 2, I'm going to load it in from Angular 2 Web Worker UI. This is the library that contains all of the UI-specific code for web worker apps. And instead of passing my component to Bootstrap, I'm going to pass the name of a background file, in this case, loader.js. So what Angular is going to do is it's going to say, OK, cool, you want a web worker. I'm going to start one up for you. I'm going to load in loader.js. Let's take a look at that. I've written it ahead of time here because it's basically just a bunch of long strings. But essentially, loader.js loads in all of your library code. So I load in system, and I load in the web worker worker bundle. And then I'm going to start up this background.js file. So what does that look like? Oh, whoops, that's the JS. Let's look at the TypeScript. So I have to write this file. This is the file that's going to bootstrap the application on the web worker. So first thing I need is my main component, which I called table demo, which is from my table demo file. This is the exact same component I just tried to run without web workers. And then I need a different version of Bootstrap for the web worker from Angular 2 web worker worker. And then I'm just going to call Bootstrap from there and pass in my component. Now, you might think, oh, but that component wasn't written for web workers, right? We have to change it. And you'd be kind of right. We do have to change it. Instead of importing from Angular 2, we need to import from this new web worker bundle. But I don't have to change anything else. This component was written with just the Angular APIs. I didn't access the DOM. So that's it. I'm done. So I'm going to recompile. I'm going to go back to Chrome. No, Firefox, sorry. And I'm going to go ahead and I'm going to try and load that application again. And we'll see if my live coding skills are actually existent. And here's the exact same application, but let's see what happens when I scroll. Get this beautiful, smooth scrolling. Everything loads. Everything's happening in a web worker. I can still scroll through all my results, but it's not freezing anymore. It's much better. OK, so there were a lot of files there. Really quickly, let's just go over them. Here is a typical Angular 2 application running without web workers. I have my index.html file. I load my app. I bootstrap. When I turn on web worker support, here's what happens. I have the exact same files in the UI in terms of the HTML. I load the web worker bundle of Angular, specifically the UI part of it. And then I load my app file. But previously, I called Bootstrap with my main component. This time, I pass it the name of my background file. That lives on the worker, so everything else lived on the UI. This lives on the worker in a separate process, so it can't block. It imports system. Now, I know we're importing system twice here, but it's going to load from the browser cache the second time, so it's not much of a performance hit. And then we're loading the web worker bundle of Angular. So we've partitioned Angular into the parts that the UI needs and the part that the worker needs, and actually not much is shared, so there's not a lot of duplication there. Then we're going to import our background file, which is going to call Bootstrap with the name of our component. And really critically, that component didn't change. The code is exactly the same. We didn't have to deal with all those problems. Now, I've got one more demo here. This is a sample Angular 2 application that allows you to load up a bunch of images. I've got a bunch of images of the Angular core team here. Oh, I don't want just Alex. Alex is great, but I want everyone. So you can load up a bunch of images. And when I click this button, it's going to apply a sepia filter to them. And it's going to apply that filter locally. And what we'd like to have happen is have these progress bars show up below each picture that tells us that, hey, some data is being processed, your application is working. But what actually happens is the browser totally freezes. We can't animate those progress bars. My mouse turned into the sort of the pointer, but it didn't go away. And then eventually we got the result. But it wasn't a great user experience. The user didn't know what was happening. This is the exact same Angular code, the exact same components. But now it's running with web worker support turned on. So again, I load up all my images. And I go ahead and I click the filter button. But this time, you'll see we get all of these wonderful progress bars. We know exactly what's happening. The process is not frozen. If we had multiple components, this component doing work would not block the other components. So that's a lot better. OK, so I've kind of hinted at this idea that you don't need to change things when you use web workers. Obviously, that's not always going to be true, right? You're running in a different context. We can't take care of everything magically for you, though I think we do a pretty good job. So what is a web worker compatible component? First of all, they have full access to the Angular APIs. Everything except actually getting native DOM elements is totally available to you. But there's no DOM access because you aren't a web worker. So you should be using data bindings instead of directly manipulating the DOM. That's kind of always been true with Angular, but now it's critical. If you absolutely need to programmatically alter the DOM, we do have APIs for that. You can inject the render and do so asynchronously. It's not really recommended, though. You should really use data bindings. But that is there as a fallback. And what's cool is that these are a subset of Angular 2 components. If you write your application with web workers and you decide, oh, you know what, I don't need it, that code's just going to work, guaranteed in a non-web worker scenario. The reverse is not always true, although it typically is. But web worker code can always run without web workers. Now, this all raises a central question. Running code on the web worker is good. It's fast. Yay. But we do want to run some code on the UI, right? This whole idea of parallelization is not run everything in one other process, because then that process is not going to be, it's not any faster, right? Sure, the browser is not blocked anymore, and that is good, but we do want some code on the UI. So how do we actually do that? And we've given you a few options. The first is to use custom elements. This is the easiest. I'll talk about it a little bit in a second. But basically, if you have a very defined thing you want to do on the UI, it doesn't need to interact with your app a lot, that's your best bet. But it doesn't have a lot of messaging with your application. Then if you need to really integrate it with your Angular application, you can use low-level messaging APIs that we've written that are used internally when Angular runs your application in a web worker. And those are a little tricky. There's no protocol to them. So we've built some higher-level abstractions to make that a bit easier. So first, custom elements. This is part of the web component spec for those of you who aren't familiar with it. So it's very new. It's evolving very quickly, but we're trying to keep up with it. Basically, you create a custom element for something that's really contained and defined on the UI. So imagine you have an infinitely scrolling table. And that table needs to do some rendering work as you scroll. Well, custom elements are great for that. You just have Angular pass the data. It renders it. If your Angular code is blocked, then the rendering is still going to continue as you scroll. So everything is fantastic there. And you can use these lifecycle callbacks to figure out when the element gets created. Communication with Angular is fairly limited, though. You just have DOM events, specifically standard DOM events. We'd love to support custom events, but right now we have a couple problems with doing that, which we're working on. So if you need more control and you need to really talk to Angular, we have this idea of a message bus. It's this language-agnostic API for communicating with Angular components across any runtime boundary, which is a mouthful, and when I wrote it, I didn't even know what it meant. But basically, it means we have this API. It doesn't depend on JavaScript or Dart. You can write an implementation of a message bus in any language that you want. And a runtime boundary is whenever you have parts of your application running in places where they don't share memory. So a web worker is a great example, but also a client and a server, or two separate windows in an Electron application, or two frames in a web application. So this is analogous to a message queue, if you're familiar with that concept. If you're not, it basically looks like this. You have two sides of a runtime boundary, in this case a UI and a worker. They both have a message bus. They pass messages into it. It has this multiplex channel model so that messages don't interfere with each other. and then you can use, the message bus uses some API internally, in this case post message, to figure out how to communicate. Now, that's all fine and good, but it's actually pretty tricky. It's great if you really want to control the messaging, but as it turns out, you have to write the protocol yourself. It's very slow, it's annoying, it's hard. So what we noticed was you typically only want to do one thing, and that is you have one side of your runtime boundary, usually the worker, but not always, says, hey, I want to run some code on the other side, typically the UI, but again, not always, and I would like to receive the result if that happens. So we've built this message broker that makes that really, really easy. And the idea is you have a service message broker and a client message broker. So it's a one-way data flow where the client requests that the server does something and gets the result back. What does that look like? Let's imagine we have a service. In the previous example, it would be the UI. So the UI has this function m. It wants to expose m to the client, and m has the following signature. So it loads the service message broker, tells it, hey, I have this method m. I would like to make it available to the client. Obviously, the client can't call it directly because they don't share any memory. So the service recognizes that. Then the client is running. It also has some of your application logic, but a different part. That logic would like to call m. So it loads the client message broker and says, hey, go ahead and call m. The message broker takes care of that. It calls m. It gets the result back, and it passes that back up to your application. So it's really easy to run code on the opposite side. We have one more really cool idea, which is this idea of a custom message bus. So we implemented stable message buses for web workers into Angular. Those exist in the Angular 2 repository right now. You can go use them. But also, one of the coolest things we did was implement an experimental Dart message bus for WebSockets. And I'll show you why I did that in a second, because I think it's really cool. But you're not limited to those message buses. If you have some custom runtime boundary, whatever your stack looks like, that you would like to run part of Angular in some place that doesn't share memory with another part, you can write your own message bus to bridge that gap. It's pretty technical. It's pretty involved. I'm not going to go into it right now. But you can go to the bit.ly link for more information. So why did I write a WebSocket message bus? So the idea was I would like to run Angular on the server. Now, I know I just said, wait, don't run all your code on the server. That's a horrible idea. So what I'm actually talking about is a local server. Now, why would I want to do that? And the reason is that I was able to build this really cool debug tool as a result. So what's happening right now is that Angular is running on a local server on my laptop, and I'm able to connect multiple clients to that server. So I have one instance of my application, one version of all my variables, one version of state. Nothing is duplicated. But multiple different browsers can easily connect to it, in theory. All right, multiple instances of Chrome at least can connect to it. This is not a good demo for Firefox. Yeah, I don't know why that's happening. OK, sorry. So I have Safari and Chrome, both connected to the exact same Angular application. And what I'm going to do is I'm going to say, hey, I'm going to enter a task in one browser. Oh, no. Everything was going so well with the live coding, I should have known there was going to be one little thing at the end that just totally died. OK, let's try this now. Cool. OK, so the server died. But I restarted the server. And the idea here is that I only have one instance of my Angular application, and it's pushing data to all connected clients at the same time. So the clients are totally in sync. I can add whatever I want in any of the clients. I can do whatever I want in my application, and I can see how it might load in different clients at the exact same time. And what's cool is that I didn't write any of this synchronization code at the application level. It's all in the framework. So you shouldn't run this on the web because it's not good with latency, but it's a great debugging tool. If you have a complex application, you want to say, OK, maybe I want to connect an iPad and an iPhone and an Android phone all to this same local server, and I want to see if I have my application in this state where I clicked on this button and then I did this, what does it look like on all these devices? Does it look the same? Which is super crucial in our applications and pretty hard to do, usually because you have to open each device and do all of those operations. Well, now it's really easy because you just do it once, and then you click in one of the browsers, and all the browsers mimic the result seamlessly. And you get this for free if you use web workers. It's the exact same infrastructure. So if your application supports web workers, you can just turn on this debugging tool. And this is one of the things that we're really excited about, is to build out more tools that are only possible with web workers, like the testing tools I talked about earlier or that demo. Now, I said earlier how many people have used web workers. After this, how many of you think you might want to try web workers? Yes, cool. Again, live stream people, you can't tell, but that was like a way bigger number. Like those 6 orders of magnitude I talked about earlier. So if you want to get started, there's a starter pack at this bit.ly link. It's basically just a hello world application, but it tells you where you can start entering your component code, and it's already done all the web worker boilerplate for you, so you can give it a try. You can get the slides at that g.co link, and all of the code is available on both the Angular GitHub has all of the framework code. It's all in there already in the latest alpha releases, and all the demos are available on that GitHub repo. And you can reach out to me at Twitter, my email, GitHub, whatever. There's an AMA at 1:30 if you have questions. Thank you.